Hello students, welcome to the next session in the distributed system. This topic is about the consistency and the replication. So this is the last topic in the second unit which we are discussing about the consistency now. Now coming to the consistency, in this we are going to discuss about the outline first of all. So in the outline we will be knowing why consistency required first. So to know why consistency, we should know about the importance of the replication, right? So what is replication and consistency we are about to see now. See, consistency is nothing but it will be playing an important role in the data maintenance, the data stores around the distributed systems, right? Now when we are knowing about this consistency term, so that we know already in the database system that wherever the file, whatever the data which we have a particular row, so wherever this row is available, that row must be available same data in multiple systems, right? So if you are considering about a file 1, so file 1 is available in system number 1, 2 and 3, right? So when we have 3 systems with the same data called file 1, so all the contents of file 1 in all the systems must be same. So that is what the consistency is. So how this we can achieve first of all. So now what is the importance, why we are getting this multiple data in multiple systems is with the concept of replication. So replication is nothing but we will be maintaining one data in many systems. So that may be mirror type or else the backup type. So whatever the type it is, we will be maintaining the same data in some other systems also, because as we are in the distributed systems, there will be a chance of crashing the systems, crashing the server itself. So thus we need our data to be available at one position, at one place. So that is what the replica we say, right? So when we have multiple replicas of our data, then all the data having the same file name must be having the same content all the time. Yes, so that is what the replication and the consistency concept. Now coming to the consistency, we will be having the two types. First is a strong and second one is a weak. So when we are discussing about the strong consistency, this strong consistency is the data where all the nodes must have same data if you are taking at a time. So when we are doing the process steps, so at a concurrent time, if we are receiving data from multiple resources of same data, all the data must be same in the strong consistency. Coming to the weak consistency, we can have somewhat, there is no guarantee that the data may be same or may not be same, but as per the rules, if we are maintaining replica means we should have the same data. Now how this weak consistency can be called as a thing means there will be final consistency time. So when we are taking any time at that moment, so that time our file 1 may be of the system 1 is having some content, file 1 of the system 2 will be having some content. Now this content may be different, but at the final time which we are about to close our process execution, at that time everything must be same. So we are giving lenience to our system that you can maintain the data, but when we are calling as a final time, that should be same. So that is what the weak consistency. Now this is the importance of the replication. See, replication will be important to improve reliability and the performance of a system. So how we can maintain the reliability means we can switch to n number of systems. Like if I am available in India and I want the data of some foreign country, all my base stations should be activated and I can reach to there. So instead of that foreign country may be having some replica of their data in India base station itself. So then and there itself I can get the data without moving all through paths and all, right? So reliability wise it will be very strong, and the performance wise also it will be giving a number of cases to improve the workload of a system. Like as we have just discussed, I can communicate within fraction of seconds. So reliability and performance will be the improvement when we are utilizing with the replication. Now what are the issues we may get are nothing but the data may be modified at one place. So this modification, how the other system of the same replica can know that, and this updation should be done in that system also, right? So that updations will be taking a lot of time. So as we are knowing, there will be one data source which will be having n number of multiple copies of the same data. So that is what the consistency problem is. So for that, how we are going to take a step is a consistency model. See, consistency model is nothing but it is a contract between the distributed system data source and all the processes. So there, all the processes who are updating the data source must be in synchronization, and they must update that particular data source from all the processes within the given time. So that may be either the strong consistency or the weak consistency. That is what the consistency model is about to create. So here we will be having three types of consistency models. So as we can see here, first one is a strict, second is sequential and casual. See, coming to the part. So when we are discussing about the consistency models, these consistency models are divided into n number of types. So now, strict consistency, whatever we have seen, just the type of the strict consistency, there the data must be updated then and there itself. Now, after the updation done only, the other process must read the content. Now, when the reading process is happening, the updation must take a lot of time to update, then only it will give the result to us. Otherwise, it will be giving just the null result, right? Now, the consistency models are divided into basically two main types, data-centric and the client-centric. So, when we are saying about the data-centric type, in the data-centric, this is nothing but your data will be playing an important role over there. So, whatever the data I have, so all the data I will be replicated to a number of systems. Now, wherever the process are entering and they are checking the data, all the replicated data must show the same data to different processes. So, that is what the data-centric consistency. So, now when we are performing read and write operations, how the data segments are behaving and how the processes can call to each other will be dependent with the time processing. So, at one time, at the x-axis, we are taking the time as a thing. So, when we are moving in one x-axis with the time, so when process 1 came and updating the same row source, that is x and a. So, we are writing on the a, right? So, we are writing process 1 and 2 are writing with the data item x with the value a, right? So, this is a data item and the value is x, a. Now, when we are updating this, see this time duration we need to update the data, and then the other process can read that. So that is what the strict one is. See, when we are writing the data, at that time itself, if the process 2 is calling that, we will be getting the nil data. See, not even the data which is already available, it will be just giving the nil data over there. So after updation is done with the time axis, then only the data will be shown to the user. So these are all the consistency notations, nothing but the terminology we are going to utilize. Wi of x is nothing but a process 1 is about to update the data item x with the value a. So Ri of xb means value b we are going to read with the process number I. Okay, so these are the types of the consistency model in the data-centric type. So strict, sequential and casual. Strict is nothing but just now we have discussed. So after the final approval, the writing process completes and it takes some time to update your value, right? So if in between, the time to update and time to give the result, in between if you are asking to read the value, it will show the nil result, okay? So this is what the strict consistency is. So as we can see here, next is a sequential. So sequential is nothing but, as the name itself saying, this is a weaker type of consistency, whereas a strict is a strong type consistency. In the sequential, it will give us some lenience to update the data, and it will be asking the user, the process to wait for some time and it will be giving the value to us, right? See, W of X A, and it is process 2 is writing and process 3 is asking B value, right? So once it is giving the value, so whatever the value at that moment will be given to the Rx of B, right? Here we will be not getting any null values. So that is a lineage given by the sequential. So sequential is nothing but one after the other. The processes will be taking the procedures. I mean to update or read or write in a sequential format. So that is what is a sequential consistency. So all these are under sequential type. And at last, the casual consistency. See, coming to the casual consistency, this is nothing but if we are in event A, from A if we are moving to B, so B action is dependent on A. So unless until A completes and B completes only, A can give its result. So that is what is nothing but process A is dependent on process B. So unless process B completes, process A cannot give the result. So this is nothing but casual consistency where a process is dependent on the other processes. Right? So this is all about casual. Now coming to the last one, that is a FIFO consistency. FIFO is nothing but first in first out manner. So first in first out manner is nothing but this procedure is also called as PRAM. So where P is nothing but pipelined RAM. So pipeline itself says that we are going to save the request in a pipeline in the first in first out manner. Right. So wherever the queue, whatever the process comes, we will be executing that, we will be giving the result. Next process to execute that, give the result. So in a first in first out manner, we are going to give all the process 2 is executed, next process 3 will be giving chance. So like that we will be executing with the consistency model. So this is a whole summary. So linear eligibility is nothing but all the resources can share the access in the same order. Everything will be having the same structure. I mean the one after the other in a linearized way we will be utilizing. So all the consistency models are done here. Next is a client centric. We will be discussing this in the next session. Thank you for listening.